Good afternoon, ladies and gentlemen. My name is John Belkowitz. I'm the Chief Technical Officer here at Intelligent Concrete, where we specialize in the magical world of concrete. The purpose of my presentation today is to give you a progress report on 3D printing with concrete, and that is the impetus of all of this. I'm speaking directly to the folks out here who use concrete and are concerned about 3D printing and why it really should matter for them. So without further ado, let's get into a quick overview of what we're going to be talking about today. First and foremost, a background, who I am, what I do, and who I do it for. Just in case, for those of you who don't know, just a little bit of credibility behind the words that I'm throwing out there. I would like to get into the purpose of the presentation and outline the 3 objectives that you should walk away with today. I mean, it's easy to say that I'd like you to print this out and keep it in front of you and ask yourself, well, did I learn this today? And if you didn't, ask for your money back from me. This is a free webinar, so you're not going to get your money back. But I want to make sure that the investment in time that you're spending on this presentation is well worthwhile. So you're going to see those 3 objectives. Hold my toes to the fire. Make sure that I'm lining up with those objectives. And of course, the motivation, why the heck we are doing what we're doing. We'll get through those main objectives, really dive into them, and then wrap it up with a concise summary and a very important question, which is why the ready-mix industry should care. So like I said, my name is John Belkowitz. Got a PhD in mechanical engineering with a specialty in nanotechnology of concrete, and that is just the part of the iceberg. There's so much underneath the water, so much that I've done over the last 30 some odd years in the construction industry that adds to, the experience that we have in Intelligent Concrete speaks volumes. And what Whitney and I were going after when we started this, and granted, I started in the United States Air Force and went through schooling, worked through the commercial industry, but what Whitney and I wanted to do with Intelligent Concrete when we created it some 12 years ago is combine what we saw in some of those university basements, that some of these technologies that never see the light of day, or even private industry, and then of course the testing techniques and methods that you'll find in these commercial labs, and combine that with what is needed for technical transfer out in the field to create this combined level of testing and technical transfer. And suffice to say, we are concrete enthusiasts. So here are our 3 objectives, and I'm not going to belittle you in reading these out to you. What we're focusing on is building a foundation and then identifying what is making this change happen, that the foundation is now forming into a pretty nice structure. And then finally, we're going to start putting the roofing on, the cladding on, and outfitting the house a little bit with case studies that have been done. Ultimately, what I want to do is create this house which contains the very ideas of 3D printing concrete, from its birth, its adoption, to that saturation in the industry, which of course is the future. Oh, that was really poetic. The motivation behind this is that the industry is growing. And of course, the motivation behind this presentation is that the industry is growing in this direction. You can resist it. You could be angry. You can try to be obtuse or ignore it. But based off of this chart, and I know this chart, I'm not expecting you to read this. As a matter of fact, I made this text so small that you couldn't read it. But what it shows is the different projects, specifically 3D printing projects with cementitious materials over the last few years. And you don't have to be a scientist to understand that the dots growing means more things are happening. So whether or not you want to embrace this is going to invade your space. And hey, might as well understand it and see if you can work with it. See if it can be a tool in the toolbox. And that's really what 3D printing is. It's not some animate beast who's come to take all your business. It's a tool in the toolbox. So that's what we're going to be talking about right now. The recent techniques, materials, specification activity, everything that really lays the foundation, and how it all began. I mean, we can go back as far as the 1950s to talk about this this comic book or this science fiction story that talked about a molecular spray for building structures. And then in the 1980s, we started seeing these inventions, these patents for 3D printed design. And then, of course, in 88, we have our first fused deposition method in somebody's garage. And doesn't it always start like that in somebody's garage with, this type of construction that we see today, the early footprints, if you will. And funny enough, one of the founders of one of the major 3D printing companies out there with cementitious materials started out in his mom and dad's garage. So it's funny that a lot of these stories start out with the founder having a really cool idea, not knowing the material and not knowing to say, I can't do that, and just figuring it out on their own. And when they did that, it was a 3D printing platform that might look something like this, all the more realistic. It was probably a lot prettier, and we're going to see one here in a second. But I wanted to break it down for you real quick because we have some very important components. The first one is our cementitious mixer, and you're going to see some of these definitions on the next slide. The first one is our cementitious mixer. That could be anything from a ready-mix truck. It could be a vertical shear mixer or a rotary mixer. It could be a bucket mixer, and you're throwing the bucket into an auger. And that's the next thing, is a pumping system. Now, pumping system, dependent on the material, could be anything from an auger or a conveying system. And then ultimately, there has to be either a manual system with hand cranks and gears, or there has to be a computer automated system with an XYZ axis that is regulating where the nozzle and pump assembly go to extrude said material, that cementitious inks. And of course, we have our printing platform that could either be stationary or moving that hosts that 3D printed material. And again, please bear in mind, this is not to scale, but all of that comes together for our additive construction or additive manufacturing system, which is normally user controlled or computer controlled for the placement of material to make that three-dimensional structure. And what we're going to get into here a little bit is the importance of that, what I like to call cementitious ink. And I believe in the ACI 564, they're changing that. I started off using the phrase cementitious ink to purposely piss people off. And it did, and it got folks excited, which I love. But now it looks like either cementitious materials or something else is going to be used. But ultimately, what we've seen with 3D printing is this evolutionary step from, a non-sanded grout to a sanded grout, and then a mortar, and then a concrete. And where we're at right now, this concrete phase, is why I'm giving this presentation. It's why it's so dang important. All right, and of course, we went over our 3D printing system. So let's go to the next slide. Here is one of what I think just the prettiest 3D printing system out there. There's a lot of robotic arms, a lot of cranes, a lot of wire methods. I like this. I believe it's called a gantry, but it's rolling on a track. This is the Vulcan printer by Icon. It's rolling on a track. It's got a XY on the gantry, and it deposits the lavacrete onto the platform. Now, just so we know, I'm going to include two more slides here. I want to include Apis cores, and I call them SIBE construction, but I just want to show, and maybe even one from these different types of printers. Right now, this kind of looks like a flippin' sales pitch for Icon, and I want to make sure that we're being altruistic about this and not making a sales pitch for one company. That definitely was not the intent. So, what has driven, this conversation that I've had with a number of people is it's not the 3D printers. I mean, come on, they are just absolutely beautiful, and the software and everything is just absolutely beautiful. But what I feel that is driving this need for the ready-mix provider industry to care is not the jazziness of the printer. It's whether or not the printer can handle concrete. Now, there's a lot of folks that are using 3D printing concrete structures. Now, to me, that's just not accurate. Concrete is a very specific thing, and what they're basically using is either a non-sanded grout or sanded grout. I mean, even to suggest a mortar is very difficult in in some of the mortars that I've used in the past, there has been up to 3/8 inch aggregate, if not on purpose, just because of what has been in the mixer before, especially if it was in a truck. And a lot of these pumping systems cannot handle a 3/8 inch aggregate that folks are using for these neat or non-sanded or sanded grouts. Now, for us to go up to the concrete side, we got to start looking at the more traditional pump trucks that we use in the construction industry. So a lot of what is being done right now is you see by the slide, driven by aggregate side. And all of that has been dominated by this 2-inch or smaller nozzle. And again, they're using either this really finely ground graded sand or, through ASTM C144, I believe that's masonry sand, or what I like to call these boutique sands, these specifically mated, graded sands that folk use to get the consistent material through the pumping system. Because again, when we're talking concrete trucks, you can't control what's in the truck. You can't control if there's a one piece of 3/4 inch aggregate in there or one piece of 1/2 inch or 1 inch. I mean, that's just the reality of the contamination that we're going to see in the trucks. And that's not meant to be disrespectful. But the emerging methods, which is allowing us to get into the concrete industry, is the fact that a lot of these pumping companies or 3D printing companies are trying to get to a 3 or 4 inch nozzle. And we're going to look at one of those case studies today. And of course, when we go to that 3-inch, 4-inch nozzle, we can start using 3/8 and higher, 3/8 inch diameter aggregate and higher to make concrete. Oh, and this is a beautiful picture of, I believe it's the U.S. Army Corps working on a 3-inch nozzle. And we're going to talk about that a little bit later. So I wanted to show you some of the cementitious ink, and I wanted to talk about the important features. And the first feature, of course, is the fresh properties. The big question is the mix pumpable. And, a lot of these 3D printing companies, they don't have folks that specialize in cementitious inks, grouts, mortars, or concretes. So for them, a lot of the knee-jerk reaction solution is adding water to make something creamy and dreamy and pumpable. The next thing is slump life. We can have pump assemblies that are anywhere from 5 feet to 500 feet long. And when you look at a lot of these systems, the curves, based on where the nozzle assembly is located in the XYZ coordinate. So, there can be a change in the free fall of the material and the amount of curves, or the curves in succession, I think is a better way of saying it. And what that often leads to, what we want to see in our pumping system or in our output is this bead that has the same look to it. It has the same height. It has the same creaminess. It has the same texture to it. If there's any tearing or dropping, or as you see in this picture above, the dyeing of the layers, that's going to compromise not only that individual lift, but the entire geometry for the successive layers. So, of course, what our next thing is the setting time for successive lifts. And whether your rotation time is 5 minutes or 50 minutes based on the size of your geometry dictates how quickly you need to reach that initial and final set. Now, on the flip side of that, we have these hardened properties like, of course, compressive strength, resiliency to shrinkage and cracking, and that's something that's going to be addressed in the ACI and hopefully through 318, which is, talking about your weird restraints and shrinkage and cracking. We don't even have to put into place solar radiation or wind. You have layers on the bottom that are starting to set up and get strength so they can, support the successive layers, hundreds and thousands or tens and thousands of pounds above it. So you got restraint through all those layers. It's almost a gradient, but then you also have the drying phenomena and the volume change that's adding to that. And there's a lot that you need to do to ensure that these three-dimensional structures don't or won't crack. And it's more than just controlling the amount of water and enhancing the mix design, as well as using fibers. It's It's a whole family of concepts that you have to get into. And one of those things, besides controlling shrinkage and crack compensation, is the evaporation control. Now, once you have all of that, next thing you have to do is ensure bond adhesion. I tell you, I'll share the link. There's a wonderful paper by the group. I know it was done in conjunction with the group at NIST in Gaithersburg, Maryland. Scott Jones, who is just one heck of a champion. I'll send you his paper or their paper. And it has this wonderful section that goes over bond adhesion, and it does a cross-section of printed out layers with good bond adhesion and bad bond. You know what? I think I'm going to put that in here, or at least try to put that in this presentation. But anyway, fantastic paper to read, especially you're looking at the importance of bond adhesion. Of course, that makes sense to everybody in the room. We all know that, concrete has that ability for successive adhesion between lifts, but more so it's this structure relies on it. So we can't just take it for granted, especially when we have 5 to 15 minutes between lifts. Who knows what could be deposited on that surface that can compromise that adhesion? Okay. So the next thing is, who's really going after this? Who's helping us create the emerging technology reports, then the guides, and then finally the codes for us to regulate and design this in the field? And right now, I've got these pretty little organizations on there. Their logos, God bless ACI. But there's also the private industry, and that's really the ones who are the foot soldiers, those brave civil engineers, structural engineers who are taking these projects by storm, are the ones who are putting their best effort forward, and really the early adopters who are signing off on this. That being said, RILAM has done a great job of putting on presentations. The Precast Institute is giving some great information, but I believe it is ACI and 564. I'm happy to be a card-carrying member of that committee, is doing a great job getting information out there. Everything from mixed design to asking the questions if this is a viable option. I mean, they're just doing an excellent, excellent job. So keep your ear to the ground and don't be afraid to head over to the national website to see what ACI 564 has been doing. And one of the things that came out of one of the RILAM talks, and soon to be coming out of ACI, is this question of, is this 3D printing a viable option for our construction site? As cool as it is, all these years that we've had this awesome activity, it's rare that people ask, is this a good idea when we get into the realcrete side, of the practical side of the industry? And what that means is this cost effective, but do we have everything that lines up with it? A lot of these 3D printing companies are saying that they can print a house in less time and with less money than current construction, timber frame or concrete. And nothing against their marketing campaign, but some of them are lines of BS that they're not entirely true. That either the materials that they're using or the cost that it takes to get to the equipment over there, or the delays that they have because of, hey, these are prototypes, some of them. They're not meeting that speed, that efficiency, or that cost. And those are all the things that we do have to consider, not only in standard construction, but also 3D printing. And there's this wonderful paper published through RILAM. The link, or the citation has been below, and it asks these questions. The paper really goes through these different questions of, all right, do we have the necessary materials area? And let me just go on to the next slide. And what we've done through ACI 564 is start generating these questions that lead off to either yes, no, or fill in the blank that helps the end user decide, okay, is it really worth this to do 3D printing, or am I just doing something really fun and really cool? And that's what these lists next slide really dive into is, first of all, is the structure even, or are we even capable of making this structure? Do we have the room? Do we have the materials? Do we have the labor? Is it safe? And what we did is we created an example case study. We had a place in fictitious job site in Vietnam. It was a one-story single-family home. That concept is being traditionally used by a few companies to do sustainable and durable housing in remote areas that's hit by natural disasters. The number of homes we want to build is 5. The closest raw material provider is 150 miles away, which a lot of these job sites, that might sound like a lot, but that's absolutely beautiful to be that close. The threat level is severe, so we'll probably need some type of security measures, either a security company to come in and plain clothes or some type of secured perimeter. And the weather will have torrential downpour during construction, and there's a low level of local skill set. So when we go through the system that I just showed you, we asked the question, is this safe location for printing? And, we always ask that on our construction sites. Is it safe to do the job? Is our equipment going to get stolen? But when it comes down to 3D printing, the whole job site is reliant on one big piece of equipment. And, in my time in the military, I've been all over the world, through different parts of different countries. And there are times that we laid pallets down out of a C-130, come back to find everything had been taken, like everything to include the pallets. So it just happens to be that this part of the world, we might need some security to ensure that the equipment, which is, even if one wire is ripped off that piece of equipment, that's going to require somebody to go into a box, to take out a piece of, or to take out materials to repair that. And that costs time and resources, and we will not have a huge stockpile down there to begin with. So is the environment accessible for the space? Yes, for the homes that we want to build. Is it simple? Yes, it's a 700, 500 square foot facility. Can proper project planning occur to eliminate? Of course. And then do we have enough locally skilled folk? The great thing about 3D printing is that it literally should be at a certain point when you believe in your 3D printing system and the material itself, it should be a click and go, and it's just maintaining that system throughout. So something that you should be able to facilitate with locally low-skilled, leveled folk. After that, we do have material within 150 miles, so we can get stuff shipped in. Can the raw materials be consistently made? There's unfortunately not enough material, but if there's a place to buy materials, there should also be a place to ship materials, and we can always have materials shipped in, which of course reduces the economic value, but are these materials sustainable? And of course, in this situation, it's not enough information. And is it possible to also research alternative materials? Absolutely. Now, this is only a draft, so if you're telling yourself that, man, this seems like there's a few holes in this, or it's not as clear as you would want it to be, that's a fair assessment. And this example, while it does show that this is a positive direction for 3D printing, the entire system is currently being worked on, and, excited to see what the future holds for this. So describing emerging ideas in 3D printing, why I say emerging ideas is because in the last 7 years, this idea has taken off. And it, in my opinion, again, this is my opinion based off of the research that we've done, it has been kicked off by certain things. Now, one of the things that I saw was in 2014, there was a major contribution from NASA to Contour Crafting to start building concepts or building three-dimensional structures on the moon with cementitious ink. Or, I think it was magnesium oxide based, but it really started kicking off this popularity of the concept. And of course, social media helped with that. But then in 2018, we see that the Marines in the U.S. Army Corps, you saw it in the news, CNN, Fox News, CNBC are building these barracks using 3D printed, and they called it concrete, but at that point, it was more of a grout. And then in 2019, where I see the major change is this use of this 3-inch nozzle for bunkers by the Marine Corps. Now, man, was that amazing. But again, it wasn't really this automated system. There was a lot of folks working on that project, and we're going to see some of that here in a little bit. But in 2021, you start seeing this point and click option with Icon, with Cybe, with Xtree, where we're building not just single-family homes, but multi-story construction using 3D printing. And that's where we're at here in 2021. We've created these amazing things. And in my opinion, these are the top institutions that are really taking off with these 3D printing concepts. Penn State, NASA, U.S. Marines, and NIST are all doing great work. And with Penn State, they're the ones who are focusing on the Mars project to create a sealed, watertight container that was printed. And I mean, the work that they've done, it was also Colorado School of Mines. There were a few universities that were going after this challenge, but it was Penn State who won. And then, of course, NASA, who's going for this lunar concrete. And, proud to have been part of the initial stages of this project. It was, man, that was one of the pinnacles of my life. I remember when Whitney said that I had a phone call with NASA to do some consultation. I said, no, Whitney, it's not NASA, it's NAPA, National Auto Parts Association. And I was curious why they wanted to talk about concrete, but then Whitney said, no, man, no, love, it's NASA. And right now, NASA is working with ICON to, create not just habitats, but also 3D printing launch sites and landing sites. I mean, it's very exciting. And I feel like I remember reading that we wanted to have our first lunar structure by 2030, which that would make it only, 8.5 years away, or 8 years and change away. Don't quote me on that. There are articles through NASA to check out. The next one is the U.S. Army Corps and the Marines printing their bridges. And, these two I wanted to focus on, or these I wanted to focus on because of the amazing work that they're doing with the Marines. There's a no-quit mentality, and starting off without the most sophisticated software and then teaming up with some of the best minds in the industry to create not just these footpaths, but also create a baseline for engineers of the future. And that's what I love about what the U.S. Army Corps and the Marines are doing. And all of them are part, especially the Army Corps, of ACI 564 and contributing. So just great what they've been able to do in a very short time, not only just for, successfully printing structures, but also developing the standard operating procedures for movement forward. Also, let's get into those case studies. That's the fun part. So the one that I absolutely loved, and this is just so beautiful. I mean, you look down this almost panoramic view of the barracks that were built in Champaign, Illinois. They printed 2 halves barracks without covering in 24 hours, and that's very important. There are a lot of these companies that are printing in a bubble. And printing in a bubble is a very safe thing to do. It takes time and it wastes money, but you don't have to worry about controlling the environment or what the environment is going to do to the print, which is a random factor that can destroy the entire structure. You can print in a bubble and just print and go, and then pick up your bubble and move it to the next structure. What the Marines did here is they printed it uncovered, unprotected, which is, it's expedited, it's real world, and of course it makes you more expeditious when you do that. You don't have to carry as much around with you. The actual structure took 40 hours to print, 80% of it, and the structures were 500 square feet for barracks. The issues that they had with this is that the material wasn't that great. I say concrete, that's what they called it, was drying too quickly. They had a lot of equipment failures. And because of the drying, they didn't get a nice print. They had problems with either pumping issues or the lines being clogged. But the consistency and the quality of the flow was lacking. That being said, they still printed. Now, the next major project that they did was a bridge in 2019. And I remember calling Brian Green, and of course now it's Eric Krieger who's taking care of it from the U.S. Army Corps. And I remember calling Brian Green. I was just complaining to him about how ugly this was. And I'm picky. I get it. I married up in my life. I knew, I always wanted to see the best, not only for my personal life, but business as well as the concrete industry. And when I look at that, when I look at this picture, I don't see pretty. And I called Brian Green about this. And if you don't know him, he's a great dude, great guy from the U.S. Army Corps, one of my mentors. And he said, hey, man, are you kidding me? They did this out in the field with no trained people in either concrete or 3D printing, and they did it with locally sourced materials. Now, the fact that this bridge was a success, that tells you that this is possible for a larger industry. So why don't you show a little bit of respect? And then he went on and on and on. So this is an amazing success. And I didn't realize that, but of course, after that berating from Brian, it's called B squared, I was blind. I can now see the value of this. And that's why everybody in the room should see the value in it too, and where this industry is going, because we're making those next steps to it becoming something that's or viable for our construction industry. And of course, the next thing is, this house that was printed and sold by Icon in Austin, Texas, or is being sold, I should say. Icon has done a lot. You're going to see a lot, or you're going to see another structure that they built. And the reason why I show this company is because they do have no fear in taking that next step. They don't understand what no means. And I'm proud to say that I worked with them for a year in creating the foundation for what is now this growing company. And, working with the founders, Jason Ballard and Alex LaRue and, Evan Loomis, there are no apologies in the way that they're doing things. And this structure, it's a 3D printed structure. It's multi-story construction. They are combining timber frame, but they are disrupting, pissing off not just the construction industry, but also the real estate industry. They're selling houses, the type of houses what we would expect people to want differently than we've seen in the construction industry moving forward. Their homes are for sale in Austin, Texas. They provide value savings, all that jazz. But even outside the higher end industry, what we find is, Icon's, I believe it was their first, their initial mission was to end homelessness because of natural disasters. And this was something that was created by their CEO, Jason Ballard. And a place that they started this was in their hometown. I believe they built 10 homes, please don't quote me on that. Wonderful article, CNN or Apple TV, I think, did a documentary on it. But they're building these one-level homes, disaster-proof homes, at least natural disaster homes, 400 square foot, and they're building it in a place called Community First, which helps people who've been down on their luck, folks on the street, homeless, get back on their feet and try to build their lives back up. They've also done a project like this in Mexico, where I believe they were going for 50 homes in southern Mexico, and it was the same thing, natural disaster-proof homes and relieving folks who are homeless. I mean, it's an awesome concept, and in places where you don't have either the skill set or even just the volume of folks to do labor to build, as many houses they did in a short period of time, this is amazing. I mean, building communities where there once wasn't. And I wanted to summarize this, that, there's an opportunity to give yourself another tool in the toolbox. And I know that, especially for folks who've been doing this for years, my Uncle Richard has been a bricklayer since, I think, 1964, 1965. And when I show him, this 3D printing, he has a very intense reaction. And, of course, as not just a bricklayer, but, he does a lot of timber construction. He feels like this might be taking some of the space. But, there's a lot to be said about replacing timber construction with concrete construction, the durability, the sustainability of it, especially as we move closer and closer to ready-mix concrete, and we can start looking at recycling materials into this, cementitious ink. And, using traditional concrete as opposed to grout, which happens to be more expensive and tends to go through more shrinking and cracking than standard or traditional concrete, it gives us a greater opportunity to bring value not only for the construction sector, but all sectors that are related to this, whether it's the ready-mix industry, the material industry, or the labor side of the industry. And as it stands right now, and before I get into the next part of this, or open up the floor for any questions, it's part of why the ready-mix industry should care. As it turns out, and I really don't want to play number games here, but there is a labor shortage within our industry. I've read a whole bunch of reports. I've read about 15 reports now. JT and I were talking about this the other day. Not one of them, the numbers aren't lining up, but the one thing that I do find, the trend, is that the labor shortage has increased compared to 15 years ago, 10 years ago, and 5 years ago. And that's quality labor. Now, why we should care about this, again, this is another tool in the toolbox for my contractors out there to get the job done, to get that critical path lined up again, and to start getting on more and more job sites. Outside of that, when it comes to why should the ready-mix industry care, why should Colorado ready-mix industry care, y'all, we've got some great materials out here. It's rare that folks have this much rounded rock and clean sand left. And with that, it's very important. Those materials are very important for making not only a pumpable mix, but a printable mix too. Now, as it also turns out, we have a lot of powder to choose from. We have different cements. We have different alternative supplementary cementitious materials as well as cementitious materials. And of course, we're located in a beautiful spot to get some of the prettiest admixtures the industry has to offer. Now, when it comes to it, we can use 3D printing for anything. The reason why I showed the case studies I showed you, it showed you infrastructure as well as low-income housing, high-end residential housing. There's a lot of industrial applications for this, not just printing structures for homes and buildings, but you can start getting into furniture, I-beams. The sky is the limit because it's all dependent on what type of geometry you're going to put into the printer, and then you press and go. So I was so happy to give this presentation because I knew that I was going to stand in front of you to tell you about this progress of 3D printing into the concrete industry. And I believe, based off of my presentation, you should be either curious or a little perplexed about the future of 3D printing in the ready-mix industry. And I want to open up the floor for any questions, but the reason why I wanted to give this presentation to you is because I know that within the first few years, you're going to see this technology. It's going to become a huge part of your everyday, and I'll stand in front of that statement every single day. And the reason why it's important, if you look at most of these companies, they don't have concrete specialists. They don't know how to work with concrete. They don't know how to make it do the things that you know how to make it do, not only on a paper side with our engineers and architects, but also on the Labcrete side and the Realcrete side in our batch plants. I brought this to you today because you are the concrete superheroes. Now, I'm about to open up the floor for any questions, and I want you to give me the tough questions. I don't mind answering them, and I don't mind being stumped. So I'm excited. I'm appreciative for your time. Let's go ahead and open up the floor for any questions.